Hi, my name is Shel Culp. I'm the Chief Deputy Director of the Office of Systems Integration inside the Health and Human Services Agency, and I'm also the Agency Information Officer. I'm here to introduce our speaker today, but before I do that, let me just make a couple of announcements. As you have noted, there is a videotape being made of this event, so it should be available in about a couple of weeks on the YouTube channel. Every breakout session today is theoretically oversubscribed. So looking out here in the audience, I'm not sure what happened to all of our people. So it looks like they're going to be wandering in a little at a time. And that might be a little bit disruptive. If you need to leave the event, certainly feel free to do so. But please be mindful of the camera so that Pat's quality of video is good for the YouTube channel later when you want to access that. If you are in another session later today that is standing room only and you don't feel like standing up, remember that there is a solution center downstairs next to the ballroom with the sponsors. Wander around in there, make acquaintances with the sponsors down there. There's also a lab up here in the corner of the second floor where you can actually see some demonstrations of cloud technology. So I encourage you to go look at those things. Without further ado, let me introduce Mark O'Connell with EMC, who is going to talk to us about capital expenditures versus operational expenditures. And it's probably a little interesting for most of us because we have a whole different set of requirements for asking for budget for capital expenditures than we do for operational expenditures. So when we set up this session, we thought it might be a good idea to start talking about what would be different there for us and how might we use that tool differently than we use the tool of operations expenditures differently than we use capital expenditures. So without further ado, let me introduce Mark. Mark is the CTO for the Advanced Storage Division at EMC and has been working in cloud technology for about 10 years. So he's probably got a little bit more experience with it than most of us. So let's give Mark a warm welcome.
Thank you very much. I'd like to welcome everybody this morning, and I would like to congratulate everybody on actually finding the room. I know when I was here this morning earlier and I picked up the brochure, I thought, great, this will tell me exactly where to go. And I flipped through, I said, car, where's that? And there was no map. And I'm looking around, and I had to finally ask somebody at the hotel, and they could point me up here. So congratulations on actually making it here. I think that is, in and of itself, an accomplishment. So the session overview should be in the presentation you had or the brochure you got. I'm just curious, how many of you are feeling some of these challenges? Operational budgets being cut. Okay, a couple of you. So the rest of you all have infinite budgets. You can spend as much as you want? No, okay, yeah, if you did, I'd want your job. This is happening, it's clearly happening in government with services. The budgets are being cut. You're being asked to deliver more and deliver more in different ways than you did before. It's happening across the private sector also. Nowhere are there pots of money that are simply available where you can just spend arbitrarily on all sorts of fanciful things. So what we're going to be looking at today, as Shel mentioned, we'll be looking at the capital expenditures, the operational expenditures. But I find you really can't just look at that purely in our financial terms. You need to be looking at it in the context of what is happening. What does cloud mean for us? How is it changing the data center? And then how does that flow into the cost models, how you can save money, transfer costs on the operational side, and those kind of things. And even that, the whole transformation of cloud. I'm a technologist in the CTO organization, but I always find technologists sometimes focus too much on, well, cloud is new and cool, and here's the technologies that drive it. And really, who cares? For people in their day-to-day lives, most people don't really care how much faster the processes are or how much more memory. How is it changing how you live your life? What effect is it having, and why is it happening? Is it a good thing? In the talk earlier, there's some talk about fear of change, what's happening. Is this a good thing, and is it really going to be beneficial? Now, my personal feeling is yes, I think it will. But what I like to do is I like to think of it as a journey of how this change is happening. And at least for me, I'm always a bit of a historical person. I like to kind of take a step back and say, okay, when did this change start? And how has it been affecting us? And then be looking how it's going forward. So the first example that I have here is one where I hope I'm not going to date myself too much. We're going to start out with a little bit of a quiz. And we'll see how many of you can get this quiz right. The question is, what's this? Who knows? Traveler's check. What do you use a traveler's check for? And who's used one? Who's used one? Raise your hand. Okay, so I'm not dating myself too much. What do you use a traveler's check for? For money. When was the last time you used one? Long time ago, because what happened? The world changed. What happens now? ATMs. And ATMs are everywhere. I travel a lot with my job. We have development facilities in China. We actually have some development facilities in Russia also, and I personally happen to like to travel. When I travel to foreign countries now, it used to be I would make sure I'd get traveler's checks beforehand. I would go to the airport beforehand. I would change some of the traveler's checks into foreign currency so I knew when I landed I had money. Nowadays, I assume there is an ATM at the airport. First thing I do when I land is I find that ATM and I put in my card and I get money. When I need more money, I wander around in the streets, and I have yet to find a city where I can't find an ATM on my network, and I pull out money when I need it. The world has changed. The way we access our money and the way we transfer money across borders has changed dramatically. And when you look at this, China, I was in China, I don't know, back in September or so, I needed some money, 4 o'clock in the afternoon, I went and I pulled out that money. What's so unusual about that? Nothing really. Except that was 4 a.m. on the East Coast. So my bank sees all these transactions going out at 4 in the morning. Imagine 10, 15 years ago, would you ever find a bank open at 4 in the morning? Banker's hours, 9 to 5. They can't do that anymore. Those systems have got to be available 24/7, because I could be pulling out money anywhere in the world, and I still expect to be able to get to that whenever I want. And in fact, I am at the point now where I don't bring traveler's checks. I rely on that, and I would be lost if I couldn't do that. How about some other things? Cars, banks, government. Government is a good one here. You register your car now. Sometimes you can go in, but at least in Massachusetts, there's online registration for your car. Banking solutions. We talked a little bit about that with the ATMs. But what else comes with the ATMs? Online access. When I pull out money in China, I may go back to the hotel that night and say, how much of a service charge did I pay there? I sign on to my bank across international boundaries. I bring up my records. I expect to be able to see, oh, there was a record here from 2 hours ago of what money I pulled out, and there's a service fee. And I expect all that information to be available. And maybe at the same time, I have some bills to pay. Maybe I've even got taxes to file. I expect to be able to arrange from my hotel room in China that I can go in there and I can access that tax information, I can pay my bills and do my banking, again, maybe 8 o'clock at night or so, 6 o'clock at night in China, but at a weird hour back in the United States where I normally am. So that whole access model has changed, where I expect to be able to do much more myself when it's convenient for me. And I think that's kind of the biggest thing. In the past, whenever I needed to do banking or bill pays, I had to adjust my hours to the bank because that's when the bank was open. And I made sure I scheduled my time when it was convenient for the bank because I had no choice. Now I expect to be able to do it at a time when it's convenient for me, and the bank had better be available for me to do this. And that's a big change in expectations. And that change in expectations continues. This is an example. This is something that came up when I was preparing this talk about maybe 2 weeks ago. Local site, Westboro, Massachusetts. They are rolling out a new mobile application to track potholes. And what they are doing is they are allowing residents to self-report potholes. You can have a little iPhone app or an iPad app. You take a picture of the pothole, you enter it into the system, automatically generates a work order. The town knows about the pothole, they get better information. Also automatically schedules the work order to fix it, and notifies the resident when the pothole is fixed. Is it going to end there? No, because what's going to be the next step? I've reported the pothole. Next thing I'm going to want to do is I'm going to want to check the status. When is it scheduled to be fixed? I'm going to want greater access and greater transparency. I've reported that information, and I want that ability to look at it again and find out, for the information I care about, what is the status of it. Is this purely, is this a good thing for the town of Westboro? They get more information. That's okay. Can they make this better? Can they use this information to have a better service for the residents? This is what I was thinking. How do they decide what potholes to fix? Maybe they base it on, is it on a main road or not? Is it based on, traffic patterns that they believe? Or should it be based on how many people report it? Maybe there is a pothole on the main road, but it's a bit off on the side and people can easily avoid it, whereas there's another pothole on a smaller road that's right in a really bad spot on a corner and everybody goes over it and it's a real pain. If 10 times as many people are reporting the one on the smaller road, maybe that's the more important one to fix. And that's where the town can also be looking at this new source of information, analyzing the data, and coming back and saying, maybe we should change how we order these to better serve the community and address the more important ones first, where the important ones are determined not just by the location, but by the impact on the residents. So you can be looking at this as a much more interactive mechanism where people can gather the information, be able to query it, but also on the back end to drive greater efficiencies in how you address the issues that are being raised. And there are plenty of examples of this. The other one I like to bring up sometimes is Federal Express. What happens when you send something via Federal Express nowadays? What do you get? You get a tracking number. And with that tracking number, you can track your package throughout its entire process. And it moves from that simple capability, something Federal Express needs anyway, because it needs to track the packages, but opening it up with greater transparency to where we as the consumers can access that same information and see what's happening with our package and what's going on. So the world there has truly changed. What's happening on the back end inside the IT infrastructure? Are the same old solutions going to be working? And I kind of like this picture. Does this picture look familiar? How many of you have an IT shop like this? When somebody with their web phone comes in and puts in the picture of the pothole, you got to spin up the tape drives, spool it out to the tape drive, pull it off the tape drive when it comes back. It would never work. It's not set up for the realities of today's environment and how people expect that access to their information. What's changed as you look at this is I kind of narrowed it down to 4 kind of main things. 24/7 access to your information. When I bank in China, when I'm traveling, when I'm at home at night, 10, 11 o'clock, I expect to be able to do these things. The back-end IT needs to be able to set up to be able to handle that load. The immediate update. When I submit that picture of the pothole, I expect to be able to come back 20 minutes later and see it's been received and probably be looking for an ETA of when it's scheduled to be fixed. And I understand that ETA might change, but I expect some feedback back from the site that this town has received it and is acting on that information. And this is a big one, these spikes of access. Bill payment deadlines, tax filings. How many people in this room pay their IRS taxes on March 1st? 1, okay. How about on April 13th or 14th or 15th? Yeah, a lot more. You can have huge spikes in access where for probably 350 days of the year, that system that the government has set up to receive e-files is pretty idle. I mean, there'd be a trickle of activity all through the year. People who are self-employed pay quarterly and things like that. But when it comes to April 15th, there's a sudden spike in access the system needs to be able to handle. And you see that same pattern over and over. One of the things my school system does is they give out report cards online. Well, for most of the term, do I look at my son's report card? No, there's no information there. When it comes, the report cards come out, what happens in the next, 24, 48 hours? Everybody's looking, and it's a big spike in access. And again, the back-end systems need to be set up to be able to handle that access at those times it's going to be occurring. And you see this, over and over. Report cards, potholes. They don't send home traditional, handouts anymore. They have what they call a virtual backpack, where once a week they put out an electronic PDF of all the announcements that they want the families to know. And they send out the announcement, and again, once a week, you have a spike in access to that information. So you see this same pattern over and over. The traditional solution doesn't fit in this. The traditional answer that we've been using for years beforehand has been to take each one of the applications, put it on a dedicated server, have dedicated storage with it, and you run that system. And you make sure you provision that system, you over-provision it a little bit to handle the spike. If you need some more storage or so on, you can roll it in here, and you can expand each system individually, and you manage each one very much as a discrete component. The problem with it is you can't share anything. When you have a spike in one or you have excess capacity on one, you can't use it on the others. As you try to web enable things, you work to web enable one of them, then you've got to repeat all those steps to web enable the others because they're all separate, discrete infrastructure. Same thing with general management overheads. You have to operating system on there, you've got to be maintaining and updating. If you're lucky, it's the same operating system across all of them, so you at least know the techniques once. But maybe some of them are Windows and some of them are Linux, and maybe some are Windows 7 and others are Windows 8. So you have slightly different management styles and things you need to do across the different ones. And these costs start mounting because you have to keep repeating the similar tasks over and over. So can you make this work? Sure. With enough time, money, and effort, you can make this work. But it's inefficient. And that's where I come back to my earlier question. How many of you have infinite IT budgets and you can spend as much as you want? I know EMC, we certainly don't. And these efficiencies are really inherent in that model. How many of you, high school or college probability recognize that? It's a bell curve, standard bell curve. And I think you all know in a standard bell curve, you've got your mean, and you have your standard deviations above and below the mean. And if you want to be provisioning your systems to handle, 90, 95% of the time, so they can handle the normal load, you have to provision them for about 3 standard deviations away from the mean. And in this kind of model like this, I've made up these numbers, but the basic idea, if you're normally running here right at the mean, but you're provisioned for up there, you're running maybe 60% capacity or so. And you can make that same argument that follows for your compute, how much memory you have in there, and also for your storage. You need to be able to handle some of those spikes, but because you're not always in a spike situation, you're running maybe 60% capacity. But the world isn't a bell curve. Nothing in the world looks quite as nice and smooth as that. And even in a traditional application, you get a long tail on that bell curve. And again, to be able to handle those spikes, out here, not all the way out, you accept the fact that there's some spikes that you simply wouldn't be able to handle. But to be able to handle those spikes, your average utilization is dropping down to maybe 40% or so. And that's just in a traditional application. When you look at a web-based application, and again, tax filing, report cards, and so on, you get these huge spikes part of the time. Most of the time, the load is dramatically lower. And that's where you get these huge inefficiencies inherent in that siloed approach, where maybe you're running 20% capacity most of the time, except those times when you have that huge spike. And what happens in a siloed approach is you repeat that. You have each one of these systems running about 20% capacity over and over and over. Your costs start mounting because you have the same capital expenditures multiplied by 5 across all these systems. You've got to be managing all these systems. And these are just for the normal systems. How about high availability? Do you have a separate passive system that's next to all of these in case there's a failure in this one so you can fail over? Well, your passive system is sitting there passive. It's got to have just as much capacity as original, drives down your overall utilization probably in the 10% range. And then if you have a whole nother disaster recovery site that's sitting somewhere else passive, your averages go down yet again. So yes, you can make this work, but it's inefficient. And the scaling is rad. So the new model in the cloud is to take that model, the 20% utilization, and consolidate. Bring it together into one larger system. And the beauty of those larger systems is across those 5 different silos, they're not all going to be spiking at once. By bringing them together, you can share the overheads that are designed to handle those long tails and share it between them on both the storage and the compute side. And you can get to a model you can be getting back up to that 60–80% utilization range with much lower overheads. And the example I have here, if most of your applications, the normal load is about a 1. If 4 of them are running with a normal load of about 1, and one of them is spiking all the way out at a load of 6, which is a load that couldn't be handled before, now in this consolidated model, you're right at about the 10, which is right beautifully in your operating margin. So you can handle spikes you couldn't before because you can share those overheads across the applications. And you can play with some of the numbers. The way I've set it up here, even if 2 applications are spiking all the way out to their absolute maximum that you couldn't handle before, you can still handle it in this model. You're right on the edge of what you can handle, but you can be handling those spikes much more effectively, and your overall utilization is much higher. Your costs start going lower because you have one system to build and maintain, so your capital expenditure there drops, but also your operational expenditures because you're not repeating the same actions over and over and over. You've consolidated the system down, you're able to scale with it much more efficiently, and you're able to run it much more effectively than you were able to before. And that's kind of the heart behind addressing that IT transformation and what's adjusting to those new demands that we see on the infrastructure. So this is kind of the pictorial approach. This is more of the marketing slide behind what's going on here. Consolidating single infrastructure, any device instant access, set up for a web-based world, self-service model where people can get in, as I was talking about with me, banking and things like that, reporting potholes, looking for the information, looking at Federal Express, tracking information, servicing it myself. Object architectures and scale out. The scale out part is important. When I mentioned earlier when we were talking about the silos and the HA systems, the active-passive. Active-passive, again, has some of those inherent inefficiencies because you have to provision your passive to handle just as much capacity as your active, which automatically means you're running 50% capacity. In a scale-out system, you have much smaller building blocks where each one is not so capable, but you can scale them out and have 50 or 100 of them to handle your aggregate load. When you have 100 of those smaller building blocks to handle your aggregate load, what happens when one of them fails? Well, the load of that needs to be taken up by the others, but there are 99 others. So each one of them needs to take a small fraction of the load. And once again, in those scale-out architectures, you could be running most of those systems at 80% capacity, or even 90. One of them fails, all the others pick up about 1% more, and they're still well within their safety margins. So it makes it you can run it much more efficiently, get much higher usage out of those systems that you've paid for. So your HA is taken into that. And the shared capacity allowing you to share those overheads, storage and compute and so on, share them across the applications and be able to handle the spikes appropriately. Underneath this, 2 things, or 2 main things. Compute virtualization. I think you've probably heard of some of these things. I mean, who's heard of VMware? Yeah. Who uses VMware in your IT shop already? Good number of you. Any of you using Hyper-V, Microsoft technology? A number of you. How about Xen, the Linux technology? I know Xen users. Okay. Xen is another one that's up and coming, but they virtualize the machines, allow you to have a single larger compute infrastructure shared across multiple applications. And underneath and on the storage side, multi-tenant scale-out architectures. And specifically, object-based architectures really underlie this. And the reason why object-based architectures comes down to a couple of factors. A traditional NAS system uses NFS and CIFS protocols. Those are great protocols. They work very well in a local area network environment. But they don't work particularly well once you start talking about mobile devices, internet access, and things like that. Because those protocols were designed 20 years ago, and they were designed for the state of the computing industry then. They weren't designed for how the computing industry has changed now. Whereas object architectures typically have REST-based access built into them as their lingua franca, as how they actually work. And they deliver that information over the internet, over HTTP protocols, very much set up for a web and mobile world. They're fully active, and scale out, built from those smaller building blocks. And they're the full multi-tenancy aspects, where you can have multiple applications storing their data on that single common infrastructure, but logical separation put on them by the storage system itself, such that each application sees its slice of the data, and that's it. It thinks it has full access to the architecture, whereas in reality it's time sharing it across many different applications. You have per object metadata, which gives you context about the data. In a typical file system world, you probably have different file systems for different applications, and you as a human administrator are remembering, well, this file system is for that application, that file system is for that one. When this file system fills up, I have to do this set of actions. It's doable, but it's a pain. In an object architecture, I like to think of it as a bag of marbles. And all the data I put in that bag of marbles. But I can tag it, and I can say, this marble is orange, this one is striped, and so on. And when the application needs to get it back, it could simply say, give me the orange marble. It doesn't need to worry about file systems, where the data is located. It doesn't need to worry if the file system needs to expand. The object system underneath it handles all of that. It knows where the orange marble is located, and it can pull out that orange marble whenever you need to. When you need to expand the system, this is the beauty of it, the bag just grows, and you can put in more marbles. The application still says, give me the orange marble. It doesn't know the system has grown. It just knows there's more space to shove more marbles into it. And all this comes also down to the lower cost, where the lower cost comes down to a bunch of things you don't need to do. No fiber channel networking or anything like that. It's IP-based technologies. No LUN or RAID group carving, no file systems to manage, no file systems to fill up or anything like that. Honestly, in an object-based system, are there file systems? Yes. There are file systems underneath it, and there are disks underneath it, and there are LUNs underneath it, and all that stuff. But you, as the administrator of the system, don't see any of that. It's all hidden by the object system. The object system manages that, and the object system knows that certain file systems are filling up, and it'll redirect the traffic elsewhere. It'll redirect the traffic elsewhere, and it handles all those complexities so you don't have to. And you can manage your data at that next higher level. And these things are really working fundamentally because they handle that challenge of the spikes, the multi-tenancy, the consolidation that we just talked about, and why that's necessary. So how do we get there? Now, I know one of the speaker guidelines here was avoid eye charts, and I have violated that terribly here because I suspect nobody can read this. But this is from a survey, a 2013 CIO survey. What are your top concerns for 2013? And what I've done on the next slide is I tried to make it a bit less of an eye chart, and I just focused in on the top 5. Any of these seem familiar with what I've been talking about? Consolidation and optimization. That's right in there. Cloud services, delivering services to your consumers based on this scale-out architecture. Security, I haven't talked about yet, but I'm about to. Mobile services and mobility, again, that's something that is basically being demanded of us. That as the world has changed, people are doing more and more on their mobile devices, and it's simply becoming an expectation that the information will be available via those channels. And again, budget and cost control, because nobody has infinite budgets to be able to do all this. You're expected to do this either within your current budget or more likely within a reduced budget, and yet you're still being asked to do this. So there are a couple different models that you could be going as you look at this world. One of them is going to a public cloud offering. Now, how many of you anybody can name a big public cloud provider? Google, Salesforce. How about Amazon, Azure? There's a number of them out there where they've set up these infrastructures themselves, and they basically provide storage and compute as a service that you as consumers could take advantage of. There are a couple real advantages to that. It's very simple, easy to use. You can literally go, put your credit card number in or your government's credit card number in, you get an account, and you pay for the storage, the bandwidth, and so on that you use. Very simple to use. But it's not perfect for everything. It works very well for a number of cases, but there are other cases where security and compliance come into play. And this is where, again, security in a cloud world can be a big factor. When Salesforce or Amazon stores your data, they're choosing how to store it. They're choosing how many copies to store, and they're intermingling it with a whole bunch of other data. If everything goes well, it's great. But typically in a government, payroll situations, tax filings, and so on, there are typically some very strict regulations how that information can be stored, where it needs to be stored. Does it need to stay within the state? I actually don't know the regulations, but my guess would be it does need to stay within the country at least, and factors like that. In a private cloud environment where you either own the storage yourself or you bring in somebody else to basically set it up for you and run it within your shop, you have control over those factors. And you can decide, I want to make sure I have this information protected 2 times, 3 times, or other strategies. And I want to make sure it's located within California or within Sacramento or whatever is appropriate given the situation that you're in. And you have that level of control to be able to make those decisions. And that can be a very important factor when differentiating from a public cloud. And again, private cloud can also be two flavors, one where you truly do own the infrastructure yourself, or one where you contract with a third-party company, where the third-party company basically does the physical management of it, but sets it up and configures it according to your exact needs. So there are a couple different flavors around that, and they come in again where the operational expenses start dominating the picture. There may be some capital expenses if you do true to go a true private cloud, but as you start putting the services on top of it, you could be doing chargeback and so on, charge the tax company or charge the tax department for their exact usage of the system based on metering and chargeback capabilities built within the system. You can also be charging other companies and also have better tracking of the utilization of the system based on the metering that's typically built into these systems. So you see again this focus where as you consolidate it down, you're tracking the individual applications more closely because they're using a common infrastructure, and you can get to that level of detail. See a few people smiling. You may not actually be able to charge the other departments. Maybe that's a bit of a fantasy on my part. I know certainly, at least in some of the private examples I've used, that's a typical model. You know, your mileage may vary. I do recognize that. And as you look at this, one of the things, again, technologists can sometimes go off in the weeds, and sometimes people come and say, oh, cloud is wonderful, everything's changing to cloud. And my personal opinion is, if anybody tells you all your applications and everything is going to move to cloud, they're selling snake oil, run as fast as you can. Traditional models still apply in certain instances, and they may apply simply because it's the most appropriate, or they may apply simply because it's not worth it. The level of access to that information, the style of information, or just the cost of moving it isn't going to be appropriate to move it to a cloud environment. And it's simply cheaper and easier to leave it where it is. And that will always be the case. So as you think about this model and think about your environments, this is a little picture we built up where you start looking at, across your workloads, which workloads do you have where you're just going to leave them where they are? It's not worth moving it. And it's the other workloads where, okay, that's where you can start looking public, private cloud, and those kind of things. And they may be existing workloads, or they may be new workloads. And especially a lot of new workloads fall in this category. Responding to those new demands, like the pothole application I brought up earlier, would fit squarely in here because it's not legacy, and it's being very specifically designed for that cloud world. So as you look at that, then you start looking at where is it most appropriate, public or private. There'll be some where, private workloads, you have specific requirements around compliance, where the data needs to be stored, how it's protected, and things like that, where a public cloud may not be an appropriate solution because you lose some of that control. For other ones, you'd want to be looking at, maybe a private public cloud is appropriate, but it's not a trust or compliance factor. And that's where you start looking at the functionality. Are there features or functions that I need that are more tailored to my specific environment, or can I live in a more generic public cloud environment that is set up across multiple different companies, multiple different systems, and that could be appropriate? And you can start looking at that, and you can start categorizing your workloads, and they fall into the different categories. And in a typical environment, you're going to come back with things that fall into each of these categories. Some you're just going to leave exactly where they are. Some you're going to want to set up in a private cloud environment because that makes the most sense. And some where a public cloud answer is going to be the most appropriate answer. And you'll probably wind up with answers that go across all three. And as there was another survey that was taken, what kind of things are people looking at where they're making these decisions? Email is a big one. Email, traditional legacy application on file systems and so on. But email, how many of us check our email on mobile devices now? It's a real sea change. Yeah, I see a few hands. I suspect that actually I would be surprised if is there anybody in this room that doesn't check their email on a mobile device? Yeah, everybody does. You just didn't raise your hand. Moving storage out, mapping applications, disaster recovery, that can be a really interesting one, other integration projects. So people are really looking at this and looking at moving these applications out and taking advantage of these economics. So we talked through a number of things. We talked through kind of some of the drivers behind the cloud, the change in how people are accessing information, the change in behavior with the spikes in access. That drives the consolidation of the infrastructure. It drives cost savings as you have one infrastructure to manage and maintain. You can share the excess capacity across multiple applications so you don't need to over-provision to such a large degree, and some of the models around public and private clouds and so on. What I want to talk about here is some of the other changes that are occurring underneath this, which are natural outgrowths of what we've talked about so far, but which aren't necessarily quite so obvious perhaps. One of them is data protection. In a data protection model, when you have your traditional, your block systems, your NAS systems, how do you protect your data underneath? You normally use a RAID 5 or RAID 6 LUN. How many of us use RAID technologies underneath it? Yeah, I see a few hands come up. And again, is there anybody here who doesn't use RAID? Yeah, people start raising their hand. So you have a model that works very well for that siloed infrastructure. But once your infrastructure is no longer siloed, do you need to use that same data protection methodology? Are there other data protection methodologies that can be used? And they can also start playing into disaster recovery, where you can combine data protection and disaster recovery together. And that's where cloud starts getting really interesting in terms of driving yet further storage efficiencies. So what is that? So beyond traditional data protection, I think everybody knows RAID 5, RAID 6, RAID 5. You have a number of drives. You have a single parity drive. There's an XOR operation between them. If one of those drives fails, you can recreate the data. Very simple. One of the things a lot of the cloud technologies do, a lot of the object storage systems, is they go beyond just RAID 5, RAID 6 to what are called erasure encoding algorithms. They're sometimes called Reed-Solomon algorithms. There are a couple different names for them. But the basic idea is you take that same concept of RAID, you make the math somewhat more complicated, but you allow an arbitrary number of the redundant fragments within the system, instead of just a single one with RAID 5 or two with RAID 6. The example I have up here is a 9+3, where you take your data, you split it into 9 equal-sized chunks, and you have 3 redundant fragments that you store in the system. So you wind up expanding the size of your data by 33%, but the advantage is you can suffer 3 failures and still maintain access to your data. So you have a greater level of protection than you do with RAID 5 and RAID 6, again with very similar math underneath it. Other techniques, there's what are called 10+6 or 10 of 16 technologies, where it's the same strategy. You have 10 fragments you divide it into, plus a level of 6 redundancy where you can suffer 6 failures. And the math is flexible enough that it can actually be made arbitrarily complex. You can have 12+6 or 12+8, all sorts of different schemes. So you can look at that. The advantage of a RAID is you have a greater level of redundancy for not much more overhead. But where these kind of technologies really get interesting is when you start looking at distributed versions of these algorithms. And here I'm going to walk through 2 distributed cases, a traditional one, and then I'll talk about applying those erasure encoded techniques to this same distributed algorithm. This is a case where you have 4 data centers, and you have some information you need accessible across those data centers. Traditional answer would be you simply put a copy in each data center. Very simple, very straightforward. You have full disaster recovery protection. If any site goes down, you still have access to that information, and everybody can get to it. But you have 400 or 300% overhead because you've copied the data 3 extra times. How about if you did a model where you take one of those 9+3 copies, and you split it up, and you have 3 of those fragments at each site? Now what happens when you lose one of the sites, if site 4 goes away? Between site 1, 2, and 3, you can still get access to 9 of those fragments. And when you have access to 9 of the fragments, you can reconstruct all of the data. So suddenly you have full protection against a data center failure with 33% overhead. And you can use this both for local protection, for disaster recovery protection, and high availability built in with 33% overhead. Is this nirvana? Not quite. Issue with this, what happens when you go to read the data? Well, when I come over here at site 1 and I say I want to read the data, site 1 doesn't have enough information to give me all the data back. It needs to contact at least 2 of the other sites, pull back those fragments of the information, and reconstruct it. So my cost on read is higher because I have to be traversing that network to the other sites to be able to access all the information. Is that appropriate? If it's information that's being highly accessed, like my son's report card, when everybody is getting their report card information, it would probably melt your network down. But how about, 3 months after the report card is issued? How many people are accessing the report card then? Not many. You could have it set up like this at the beginning, over time migrated to here, because 3 months from now, if it takes me an extra second or two to get to my son's report card, I don't care. And the load is low enough that the network overhead isn't going to be that high. So you can be moving to more efficient models over time as people access the information less frequently and get huge benefits and efficiencies out of that by, again, combining these things in a way that wasn't possible when all the storage was siloed. 300% versus 33% overhead. Huge differences between them in the overall efficiencies, but you do need to watch the read traffic and evaluate that in the context of how are people using the data and when is this kind of strategy appropriate. Hybrid is just another technology. We talked about public and private. We talked about kind of analyzing the workloads. We said, in all probability as you go through it, you're not going to be coming up with one answer that says everything's private or everything's public. You can be looking at models where you share access across both a private cloud that is maintained for you or that you yourself own, or a public cloud environment. Or even, again, looking at cases where report cards and other things, maybe they're originally locally on the private cloud for faster access in the local environment, but 3 months or a year later, when the access rate is much lower, move them out to a public cloud where you can take advantages of efficiencies in the public cloud, save your private cloud for information that's more fresh and up to date, being more quickly accessed. There are all sorts of different ways you can take advantage of public cloud offerings, combine them with the private cloud, and really be doing it based on the data and the characteristics to get the benefits of both worlds there. So some use cases, some things that we have seen in our own customers. Now, I will apologize here. I don't actually have government examples. We do have some government customers, but many of them aren't always the best about saying, yes, you can use this as an example. So I've used other cases. But one of them, Kettering Health Network, healthcare system. This one I thought was very interesting. I picked this one out because what happens when you look at their challenges? Siloed infrastructure. Their growth was doubling and they couldn't scale. That seemed familiar. What about healthcare? Electronic health records, access to information, all the same kinds of challenges that we've been talking about. And what did they do? They brought in what they call a vendor-neutral archive, cloud-based technologies underneath it, save time and storage costs. And this one I think is a really interesting one. So they got the standard benefits out of cloud. They're able to consolidate, deliver better service to their customers, able to have less infrastructure costs and things like that. But they were also able to use that data. Now that the data is no longer siloed, they can be using that data to make better decisions and getting further efficiencies out of that data than they were able to before, as yet an added benefit. And that is, I think, one of the big things about cloud that it really does enable, is it gives you that, or you can have better insight into your data than you were ever able to before. The next case is a financial services firm. And again, you look at what happens up here, legacy file systems. Whole system that was based on NAS devices, because that's what was there at the time. They were working on web-based scaling. They were web-enabling their applications, trying to take their legacy infrastructure, put a web layer on top of it, and have it work and scale efficiently. And they couldn't make it work. They rolled in an object storage system underneath it, the other virtualization technologies. They were able to deploy in a day, very quick deployment. They were able to actually save money because they used the multi-tenant capabilities, run development and production on the same system. That's separation of the applications using the multi-tenant capabilities. They actually saw better performance rather than having the web services, rather than having the web enable out layer, the legacy storage, and all the complexities. They actually saw better performance by consolidating and using straight web access straight to the data. They saw cost savings. It was a much less complex system, and they were able to use more applications on it than they had foreseen because of the ease of the integration. And they were able to use what we call information lifecycle management capabilities. Some of the things I talked about earlier when I talked about you may want to store the data in one way when it's first there, fresh, being very much accessed, migrate it automatically to more efficient protection mechanisms as it's accessed less frequently. Object systems can have capabilities where they can automate that transition for you, where you can establish a policy that says for 3 months, store the data in this way. After 3 months, move it to a different scheme that's more efficient. You don't have to worry about it. It happens automatically underneath it, and you automatically get those efficiencies. Final example I have is actually one from EMC's own IT department, because EMC itself is not immune from these changes, and we see these same pressures and changes that we have. As you can see, we started back 2004, 2008. And this is, I think, one of the other interesting things, and I'm okay. You see here we started 2004, 2008, it's 2012 plus now. If anybody comes and tells you, tomorrow you're going to roll in a cloud and everything's going to be wonderful, they're lying. It takes time and planning. There's no free lunch. But what happened, years ago, 90 days to provision a new application, and the IT department was spending 20% of their time or so on new value-add activities. 80% of their time was simply routine. I need more space over here. There's a server over there is getting overloaded. This network's having a problem. Day-to-day stuff. And as you can see, it didn't change overnight, but where is it now? 1 day to deploy a new application, down from 90. And this one is, I think, huge. From 20% time on new capabilities up to 42. So they doubled the amount of time they were able to spend on adding new services and new applications and making the world easier for employees such as myself to live within that environment. So that's why I can get to email on here safely and securely, because EMC was able to put in that time, put in the security on that to make sure it's secure on this device. And I also know within EMC, I can go and I can wipe this device automatically if I ever need to, if I ever lose it or anything else. They have custom security they have put on this, where I am required to have a password of a certain length, and I am required to have changes to it and things like that, and I'm required to have my screen lock within 5 minutes. So they were able to spend the time, because they have the time to spend, be able to customize this and make it work within the EMC environment and the EMC policies that they want to apply. And I think that's an exciting transformation story. So to wrap up, I think I'm right about on time. Where are things being transformed? Scale of access is being transformed. The new demands on the system that drives the efficiency as you consolidate down into fewer systems. Oops. And we get the efficiency. Themes we've talked about. You're not going to get there overnight. You've probably heard me talk, I talked about the one financial services firm, the one-day integration. It's great when it happens, but that doesn't also talk about the planning and preparation that went into it beforehand. Nothing happens overnight. Traditional access methods remain. If anybody ever tells you you're going to get rid of all your NAS systems, they're lying. A boss of mine likes to say that the IBM mainframe has been dead his entire career, but it's still one of the single biggest money makers for IBM. It's still there. Old technology doesn't go away. Some of the use cases that it was used for migrate to the new. New use cases are done in the new infrastructure, but there are some things where the old technology really is the best choice, and that doesn't change. The new paradigms, mobile, web-driven, interactive, that's really where a lot of this is being driven. And it is that journey and that transformation, and the transformation is occurring. So I think I'm supposed to finish 10:50, which I basically did. I had to watch time. I tend to be long-winded. I meant to leave a few minutes for questions. Very happy to either take questions now. I can be available for a few minutes. I think the next breakout's in 10 minutes, or I'll be wandering around later. If anybody happens to see me, I'm more than happy to take questions then also. Thank you very much.